when we looked at refraction through one surface, okay, where this surface was filled with a material and this is a different material, so we had an N1 and an N2, we got a fairly complicated equation. We ended up with N1 over S plus N2 over S prime equals N2 minus N1 over R. And we had to figure out what the sign of R was. Well, when you have a thin lens, you basically encapsulate N2 and the light comes back out into the original material, N1. And so this equation was describing where the image would form after passing through just one surface, but then wherever that is, then it's going to come back out and bend again through this surface. Now these surfaces could have different radii, they could have different radius of curvature. And so what we'd need to do is we need to do this once, figure out where S prime was relative to this surface, and then starting with this surface, figure out what it's going to do to that light, and do this again. In this case, N1 and N2 switch places. Suddenly S is now S prime, R is a different R. It's pretty complicated, so we're going to skip the math. But the result is pretty darn cool. If we assume that this is some index of refraction material in air, so we're going to simplify it in air since that's such an important case, then we end up with this simple equation, 1 over S plus 1 over S prime equals 1 over F. F is defined as the focal point. So S would be the distance to the object, and S prime would be the distance to, if this was a converging lens, I'd get an inverted image, that would be the distance to the image. Okay? And F is these points that allow us then to use our ray tracing. So we kind of assumed this when we did ray tracing, and now we can actually see where it comes from. But what's really cool is this focal length, this F, has its own equation called the lens maker's equation. And it's called the lens maker's equation because you have to actually make F from the curvatures. You know, we haven't seen this R yet. Where did it go? It's buried inside here, the index of refraction of the material. It's buried inside here. So what is that equation? It ends up being nicer to write it in an inverse form of 1 over F is equal to N minus 1, where again we're assuming we have some index of refraction inside air, so we only have one index of refraction, N minus 1, times 1 over R1 minus 1 over R2. Okay. That's the lens maker's equation. So if I want to create a lens with a certain focal length that I can then apply this to, then I would need to choose a certain material and then grind the two surfaces in just the right way to get these these curvatures, these radii, to be able to achieve that certain value for F. That's why it's called the lens maker's equation. Okay. Now, like this one, where we have to be careful of determining the sign of R, we have to understand what these surfaces, or the signs for these are. Okay, N is always positive, but R1 could be negative, R2 could be positive. Okay, so I'm going to do that in a second video.